Hi everyone, this is Fredrik Wormling again. This is the second video of this playlist where I aim to show how my research group is using or analyzing CRISPR screen data. In the first video, I showed you how we usually process data coming out from MAGEC. So if you've done your own screen and you get sort of results back. Now in this other video, I'm going to show you how you can work with CRISPR screens that already been performed in the DepMap portal. So you start by going to DepMap. I'm going to remove myself. And then you can search for a cell line that you're interested in. And if you find it, you can press it. And they have an amazing amount of data here actually for these cell lines. So you get information where it's coming from, oncogenic mutations. They show you a little bit of preferential essential genes based on CRISPR and RNAi. And you can see here what data sets they have on these. And importantly for what I'm going to talk about today, they have CRISPR data sets. And there are probably different ways of doing this, but the only way I figured out to do this, if you want to download the specific CRISPR screen data for this, is that you start by doing context manager. And you see I've already done it here, but I'll do it again to show you. Create new with cell line selector. So here are all the cell lines. I want to find A549. I press the cell line, I give it a name, A549, and as you remember I already did give that name before, so I need to give a new name there. And then it comes up here as a context type model then. And then this gives the possibility to press download, custom downloads, and instead of using all cell lines, use model context. And now we have A549 that I just created, right? And if you click this one, then you can then select which data sets you want to download. And now we're talking about the CRISPR. So I would suggest to use the top one, which is the most latest update. We typically often also download expression if you do these sort of things, because that could be easy or interesting. But let's look at the CRISPR now. And then we press download. Sometimes this takes a little bit of time. Sometimes it's faster. Yes, and then we get the file here, right? And if I press this one, and I'm the type of lazy person that typically use Excel, it resonates with me. And if I just open this with Excel, you see this does not work in a good way on my computer. So what I would want to do here is to transform this so it's more easy to work with in Excel. And that shouldn't be complicated if you know some programming. If you don't, nowadays we of course have the fantastic capacity of things like ChatGPT, where you can just take your file, you pull it in here. I did it here before just to test it. I'm going to ask it to transform this CRISPR screen data set, making rows into columns. I want the Excel compatible output file. I press here and it's thinking a bit, and just so we don't have to wait for that, I already did before, and then what you get is a download an Excel file version, and we get this CRISPR transposed file. And instead of looking like this, it now looks like this, and something we can work on, right? So I'm going to enable editing. I'm going to remove or format it a little bit so it looks like maybe more like I like it. You see here that it doesn't say A549. It has this name or number that DepMap is using. I encourage you to go to DepMap and just search for this name just to make sure that it's the correct cell. Yeah, so you see this is A549 again. So we know that it's correct, A549. And now we can start doing like we did in the last one, essentially the same. We press filter, which gives us the possibility to sort from sort of smaller or from larger. In the previous video where we looked at MAGEC data, we got log fold change and we got the FDR value, statistical value. Here we get a gene effect value in DepMap, which is very similar to the log fold change. this, but they adjust for certain things. I think copy numbers and other things. So it's not exactly the same. So here we can't use the trick that I used with the MAGEC file to just go for a statistical test that we think is significant. What I would do with this is to sort of choose something that seems relevant. So maybe above 0.5 or below minus 0.5 as sort of a cutoff that could be relevant for these numbers. And again, as with what we talked about in the previous video, we see fairly few genes with a positive value, meaning that if you knock out these genes, the cells like it, they expand relatively more. But we see a lot of them with the negative values here, right? In the previous video, I said somewhere between 1,000 and 2,000. And I think we can, if we use a cutoff of minus 0.5 here, we got somewhere in that ballpark. So something like this, right? Somewhere in that ballpark. All right, so this was an example of how we can use CRISPR screen data that's in DepMap. So remember, DepMap has more than 1,000 human cell lines that have been screened. You can search for any gene that you want and identify how knocking out this gene is affecting the cells. You can look at the histogram here, and here is the gene effect value. And that gene effect value is the same as the value you look at here. And that you look at here. So you get histograms for all of these 1,000+ cell lines. You can also press perturbation effects, and then you see the gene effect for individual cell lines. So again, here's the histogram. Here it's separated based on different cell lines, and you can hover over to see which cell line these actually are. And also there's information about sort of if there's actual mutations in these genes or not. Anyway, so that was a little bit about DepMap and how you can download and process the CRISPR screen data that's in DepMap for different cell lines. In the previous video, as mentioned, I looked at your own data. Here is deposited data into DepMap, and in the coming videos we're going to start to look at different ways to analyze the data and trying to make sense out of it. And so thank you for watching, and I hope you learned something.